Hi, my name is GRoy. I'm a senior software engineer at 514 Labs. I have an air quality sensor in my apartment. It's an air gradient monitor that tracks CO2, PM2.5, temperature, humidity, and more. The company stores my data on their cloud, but they keep only about 150 days of history. After that, it's gone. I want to own this data forever, and I want to actually do something useful with it. By the end of this video, I'm going to be able to ask an AI agent things like, can you find trends in when the CO2 level rises significantly for the last 150 days? And it will write SQL queries, analyze the pattern, and give me a real answer. I'm going to use MooseStack to set up a full analytical backend over my data, and I'm going to do it in under an hour, purely by prompting an AI agent in Cursor. Now, obviously, this video isn't an hour long. We'll be skipping over the parts where we're waiting for the LLM to finish generating code. But everything you see built here was done through the agent. Here are the steps we'll be going through. Let's dive in. First, let's scaffold the project. I'll use the TypeScript MCP template from Moose to get started quickly. So let's do create Moose app. This is the name of our project, Air Quality Monitor, and this is the name of the template we'll be using to bootstrap quickly. All right, let's get into this. Let's start Cursor here, as this is what we'll be using to vibe code our way to completion here. Let's make this a little bit bigger. And also install the dependencies. So what we got here is a monorepo. The TypeScript MCP template contains two apps, a MooseStack app, which is a full analytical backend, plus an MCP server that comes baked in with this template, and the Next.js app that contains a chat interface that is already connected to our MCP server. All right, before we can store anything, we need a data model to work with. So let's start the session with the agent about that data model. All right, let's give it some context. So analyze the monorepo we have here. Initial goal will be to create the data model. I'll give you a curl command to get the result, and you can create the OLAP table out of the result. Use the replacing merge 3 Clickhouse table engine for this OLAP table. Make sure to have a proper ver column and some proper order by fields. That should be enough. Let's copy over that curl command and let's see what it comes up with. All right, let's look at the result. So it updated the model and created an interface from the result of the endpoint. Okay, let's accept this. So it's easier to read. And here is the OLAP table it created. This is great. So now let's start our MooseDev server. From the root of the monorepo, we have this to start just the project that's running Moose. Now we need data flowing in. I want to pull the current measurements from the API every 60 seconds. Let's write our next prompt. Create a Moose workflow that runs every 60 seconds. It pulls the AirGradient API every 60 seconds to fetch the latest air quality readings. Being a bit repetitive here, but doesn't matter. It still has the endpoints in its context. Send the pulled data to a new insert stream that writes into the OLAP table. What we want here is a temporal workflow that pulls a snapshot of the data every 60 seconds, sends it to a Kafka stream, and then this stream is going to insert into our OLAP table. Let's see what it comes up with. Great, it's done. Let's look at the result. So I created a new page, duplicated the interface though. We could probably ask it to fix that and use the same interface in both cases with a function to map it. All right, so here's the workflow. So this runs every 60 seconds and it basically fetched the API and write to the stream. Nice. Let's look at the stream that it added. So as easy as this with Moose. It's a primitive. It's a new stream. It creates a Kafka streams for you. And it created a consumer. And here it just sends to it. Nice. So if we look at our dev console here, we can see that it already did a couple. Nice. Great. Now we have data coming in, but I also have about 150 days of historical data sitting in AirGradient's cloud that I don't want to lose because it gets erased after 150 days. So let's backfill this. There's another endpoint from the AirGradient API that returns 5-minute averaged buckets. So let's start with, let's backfill 150 days of data from the AirGradient API. Endpoint for this. What else could we say? How do we want to run this? Create a standalone TypeScript script runnable via a package.json script command like pnpm backfill, for example. Let's see what it comes up with just with this. Actually, I'm curious. Considering that this is, I don't exactly know how this endpoint works. I'm curious what it's going to do. We might want to ask it to go look at the online data to understand how it works. Idea of having it as a TypeScript side script is that if eventually we want to put it inside of a workflow for reconciliation, that could be a thing. For now, we only need to run it once. I want to have the data, and it's going to be useful for the next few steps where we want to analyze that data. So the historical API returns a array of 5-minute interval readings. Compared to the current endpoint, and as a data point field, let me create a backfill script. Great. Let's see what it comes up with. All right, so it's done. Processing as updated. So what we could do is run the script yourself and look at the data inside the Clickhouse instance we have locally, if that worked. Iterate until the script gives us what we want. For these kinds of backfill script, actually, I think it would be better if it tested one day, and once one day works, then do the whole thing. So let's tell them that. Add a new part to the backfill script where you validate that it works on one day first. Then when this is successful, you do the whole backfill. This should shorten up the iteration loop for it. Otherwise, I think it was just trying to do the 150 days, then seeing that it was failing, then restarting, instead of just, trying to make it work with one day first. Nice, I think it got it running properly now, and we can see it's almost done. So now let's start our front end. This command will start only the web project of our monorepo. All right, so let's look at this. This is what we have. It's not much for now, but we have this that comes baked in the template. What can you help me with? Data discovery. All right, cool. Let's test it out with something more interesting. Can you find trends with CO2 level rises for the last 150 days? CO2 level trend analysis for the last 150 days. Upward spikes, peak to extreme spike. Okay, this is really awesome. All right, now that we know that it's connected to data properly, and I can even chat with my own data, I want some graphs in there. I want some graphs in here. Let's add a new page at the root of the next tab. It be the board page. I want a graph of the CO2 level over time in the last 100 days. Let's start with this. If you need React components to help you here, check out ShadCN and use it. Let's see what it comes up with. Okay, it's done. Let's look at the result. Wow, okay. Even got max, min, and average in there. This is cool. Okay, I love this. Let's add more then. Add another graph for each metrics that we have in the DB. You know what? That might be too much. Add another graph for temps, humidity, and what's the other one that exists for air quality? It's PM 2.5, I think, something like that. So let's see. Let's see what it does with this. Okay, it just finished. I'm hyped to see what it came up with. Did a little bit of layouting too. Interesting. Okay, let's take a look. So now we have temperature for the last 100 days. Again, with min, max, and average. A relative humidity. Yeah, it's getting low here. And I could still chat with the rest of my data if I wanted to. This is amazing. So let's recap what we just built. We have a polling pipeline that grabs air quality data every 60 seconds. We have backfilled 150 days of historical data that we would have lost. We can chat with an AI agent that runs real analysis on the data. We have a dashboard to visualize it all. Almost all of this was written by an AI agent in Cursor, with MooseStack handling the infrastructure, the database, the stream, the API layer, all of it. If you have any device or API spitting out data, whether it's a sensor, a smart home device, you can build something like this in an hour. All right, that's it for this video. Link to MooseStack in the description below. Thanks for watching.